and thanks for attending this session. Today, I will be talking about an important area of Gen AI adoption, that is dealing with trustworthiness of Gen AI. It is one of the pillars of responsible AI and overall constructs of AI governance. And as you have noticed that Gen AI is being adopted in the enterprise widely, this is one area that is a lot of focus. But let me first start with a short intro. I am Santanu. I am working on emerging technologies for a leading regional bank here at Singapore. I have been in this space of digital technologies and innovation for a very long time. I had worked in tech startups like Apidays. That is why I love APIs, and I'm here at the API Days. And last few years, I have been doing a lot of work around the adoption of AI-related projects. And here we go, without further ado, into the agenda. So I will be talking about the challenges of having trustworthy Gen AI. That's something very special about Gen AI. I'll also highlight that besides trustworthiness, there are certain external threats. This is also sort of different kind, and it needs special attention to understand and deal with it. And finally, I'll cover some strategies to mitigate these challenges and risks. As the risks and challenges are emerging in nature, so are the strategies, right? So it's point in time, it's still evolving. So with that understanding, let's dive into the challenges of trustworthy Gen AI. I'll point my mouse on a few areas. So let's start with, the Gen AI models, which are the foundation model or large language models, right? These are inherently, extremely opaque. And as you can understand, that is because the nature of the models with billions of parameters, very difficult to really understand what's going on, and even it's difficult to understand what's going in, and if the complete, expected output is mapped to any, test data or something. For example, if you are using XGBoost or, like other learning models, then you can still get a sense of what fields are important to the model. Then you can do some statistical way of like finding some relation between the input and the output sets using sharp, and those kind of strategies. But in case of LLMs, it's particularly difficult for you to explain what is going on with the model, right? Then there are the aspect of data. In case of large language models, the amount of data that it is trained on is quite huge, and there is also a lot of debate about whether it's breaking copyright laws and stuff like that. On top of that, the LLMs or agent AIs also use some data for the runtime. That's also not trivial. They use vector databases, they might use short-term memories, long-term memories, context data, history. All of that together plays a role in the input and output, right? So sometimes it might have training data remnants, it might have bias amplification with regards to LLMs, and those aspects are difficult to address, not so easy compared to the other areas of machine learning. Now, let's also talk about the autonomous nature of some of the applications that we use in the world of LLMs, right? These applications are often iterative and autonomous. We also use tools autonomously, and that lead to sometimes unforeseen outcomes because tools could be very powerful and also could be resource intensive. Let's move to the next point, which is about NLP, natural language. Most of the use cases of this generative AI have one way or the other natural language in the input or output, or both, right? So many traditional methods that can do checks and balance in understanding what's going in, what's going out, or even to evaluate is not applicable to natural language, right? The traditional firewalls won't do very well, right? Your test cases will be more complex with natural language. Assessment of the outcomes will be very difficult. And last but not least, the gen applications themselves inherently are non-deterministic. That's due to the LLMs or the foundation model themselves. It can return different results for the same prompt at different times based on the internal calculations, state of the memory, and so on. And that is very challenging with the nature of the black box, these applications. So I'm sure many of you have seen these challenges and very familiar. Let's also look at some little bit of inside of under the hood, right? What's going on in Gen AI applications. It's a novel architecture, and you might be very familiar with some of them. Just a very simple one to just have an understanding of how these unique challenges and threats play out with respect to the architecture, so that gives us a better understanding. Okay, so let's take a look at some of the elements. So if we look at the front end, where the user query is entered and the application front end probably does some authentication authorization, maybe unpacks the data, and then it basically sends it to the next part, which is the orchestration, and sometimes can have agent AI elements inside it. So at this level, right, the prompt itself could be malicious, right? It can intend to bypass the control mechanisms because it's a natural language. Things can be hidden inside. There are lots of examples in the public domain to look at how the prompt, in different kind of malicious prompt embedding works, how people try to hijack the application using crafted prompts. Then it can also be directed at overloading the whole application by using tools that embedded the application, so it can instruct the application to use the tool as well as in a way to hopefully, then try to extract an uneven amount of information or just overload the system for availability concerns. So then let's move on to the data side of things. Once the prompt is entered into the application, then the internals of the application, it will basically try to enhance the prompt with context information, right? It is not just what you, but you also get history or try to understand what is the prompt. So you extract additional information from the databases. And some of it is in the short-term memory, some of it is in the long-term. So for example, the short-term memory might have information about the current conversation. The long-term memory could be something related to the topic, as in the reference vector database embedded in a form which can be used for similarity search, and more relevant information can be surfaced. So with all that information, then the overall prompt will be sent to the LLM, right? Now, at this stage, if the prompt context is, not very good, if the retrieved context is irrelevant, and sometimes even, data could be poisoned in the short-term memory by adding more and more, malicious stuff into the chat session. So all of that together can result into unexpected behavior. It could result into hallucination, which is a very common thing. So that is because if your data retrieval, if your context retrieval is not working very well. So hence, at all of the stages, things need to be monitored and tracked. And that's the part I'll talk about later, right, in the observability slides, which is one of the strategies to mitigate these threats. But let's first finish the next scenario, for example, in the prompt management aspect. So in the prompt management side, now that we are ready with the prompt plus the context to be sent to the LLM. Here, we will also want to apply system prompts, right? So system prompts are something which is basically adding some sanity, making sure that there are some constant, system level instructions to the LLM to work within certain boundaries. And here, if the system prompt is not well crafted, it can be bypassed. People can, escalate their authorities. It could also result into very inefficient prompts because it's not crafted well. It could be too long. It could be so that it is losing lots of, relevant information when sending the input to the LLM and so on. The next one is, it's a bit familiar stuff. It's like access and privilege issues that can have multiple levels. Your databases can give out information that it's not supposed to for the specific role. Your application front end might be not able to apply the appropriate level of authorization. So these are the sort of standard kind of risk, but some of the new ones around the role escalation using the prompt, or in the vector database, if you don't have access control, then it can also lead to reliance on the application layer itself or the prompt management layer itself to decide who can access what or who can title what kind of data. That should not ideally be the case, right? Now that we have understood what is under the hood, let's try to find out in a summary slide, right, the overall landscape, how does it look like? So if you look at this slide and just take a cross-section of different kind of challenges and threats, you will see that they can be sort of classified into 4 or 5 broad categories. A lot of them fall into the input manipulation category or the prompt injection sort of category, where natural language is used to cleverly bypass all controls and then try to take over. Some of this is related to behavioral risk like hallucination, because you did not understand the context well, you didn't get the goal of the conversation very well, and that results into hallucination. It could also result or stem from the vector database returning inherently irrelevant information or something like that. Then there could be challenges of repudiation, which could be due to lack of traceability, not able to understand the overall accurate, nature of the inputs and outputs, and where the, information is getting lost or where the control is getting lost. Right? There could also be tool misuse, which can lead to sort of, repudiation issues. Then data-related risks. Of course, the risks of getting the memory, short-term memory, corrupted. Also, the vector embeddings could be inverted to get back the original data set, to reconstruct the sensitive information. And then the access privilege related issues, where sensitive information can be extracted from the LLM, or even force the LLM to have role confusion, right? So with this kind of understanding of the architecture and what are the major threats, now let's jump to the different mitigation strategies that we can look at today. And as I said, by no means it's a very comprehensive list or anything. It's a evolving set of strategies that I have come across, and I would strongly recommend you to be aware and start looking at these options in your respective deployments. So let's start with AI guardrails. The way the AI guardrail works is it sits as a firewall, or you can think about it as an API gateway, internet gateway between the user input and the LLM application or the agent application, right? It can very well do filtering of inputs, identify if something is malicious, inappropriate, toxic. It can also filter out something that should not go out to the end user, right? Because the LLM is tricked into sending out bad information, unintended information. So the output also can be filtered. It can work based on rules and policies, and it should also have capabilities like AI-driven capabilities to understand natural language, intent, it should be able to evaluate the responses appropriately to apply those filters. To be honest, some of the new versions of the foundation model already comes with some of the guardrail capabilities as an inbuilt feature. But because the foundation models are again like a black box, you cannot fully rely on them. So you need more explicit way of having a guardrail in front of your application. And these guardrails are different from traditional network level firewalls, because these guardrails need to understand natural language, need to understand data extraction issues or such attempts. And it gives you a runtime control, right? The next one is observability. So this is again to give you a real-time end-to-end visibility and ability to trace, track, have post hoc accountability of how the AI systems are working, and give you an opportunity to fix it in the feedback cycle. Some of the key features of this are that you should be able to understand the entire application flow, trace of thought, and how the agents are being used, how the tools are being used. So complete mapping of each of these calls, each of these requests, and the responses end to end. You should be able to track various metrics which are relevant for GenAI applications like hallucination, goal creation, and so on. On top of that, you should be able to, attribute some of the behavior to, like, oh, this is a problem with the vector database not returning relevant content, or this is a problem with the role escalation. This happened, something went wrong on a specific component. So that kind of ability to debug and understand the end-to-end behavior component by component, right? And then because it's observing the whole landscape end-to-end, it should be able to give you alerts, and it should be able to give you information if something wrong is going on, if there's a sudden spike in a certain kind of request response, if there is a sudden unusual API or tool use. It's not just at the ops level or a infra level, but at the application level, what are the behaviors being observed, right? If I can project some examples of how some of these GenAI specific observability metrics look like, you'll get an understanding that if you read just the first couple of bullets, maybe in each of the category, I think you'll get a sense that these metrics are so different from traditional observability metrics for other kind of applications or infra. And it is so because the GenAI observability requires a set of evaluations to be able to measure these metrics, right? And this is the additional capability to measure the input and output on those areas, and then start generating metrics, trends, alerts, and so on, right? So, for example, how do you measure hallucination rate without fully evaluating the request and response? And then have some ways to like apply even rules sometimes to rules, and sometimes AI-driven intelligence, adversarial kind of capabilities to properly assess and evaluate each of these kind of metrics to start even getting sense of it. Yeah, so that's the point I wanted to highlight, that AI observability is inherently different from just monitoring the system level metrics, or monitoring the application level metrics, or just logging the entire input and entire output and then trying to do debug later. It's much more than that. It's like a real-time visibility based on intelligent evaluations. Now, all of these features or all of these capabilities might not be there in the tools and evolving products today, but I think where the market is moving towards, and a lot of tools are providing 60, 70, at least 50% of these required features. Okay, then let's talk about adversarial testing, which is something like scanning the model before putting it to production, not just runtime. You need to be ready even at the design time, at the development time. In your DevOps pipeline should have automated scans to understand if there are inherent vulnerabilities. So it's similar to the evaluations that the AI observability tool does or your guardrail does, but it is done in the design time before releasing, right? And it's much more extensive in that sense because it gives you the opportunity to find out issues before it is actually released, right? And it's different again from the traditional DAST or SAST like scanning tools because they are doing pretty much rule-based scanning of your code or known vulnerabilities. But the set of testing that these Gen AI vulnerability scanning tools are doing are based on different set of tests together. It's a lot of these are based on natural language. A lot of these are based on jailbreak attempts of the foundational LLMs. So there are some databases that are evolving in Mitre and other foundations to kind of keep these threats updated. Okay. And then, of course, last but not the least, traditional ways of securing data and applications still apply. So that's where the standard practices like encrypting data at rest and in transit, for example, you probably should be better off by encrypting your vector databases, right? You should also look at data governance aspects, how to make sure that the AI data doesn't get into the training in the first place, or the LLMs or the tools do not get access to them. Should also make sure there are role-based access controls in everything that you do in the tool level, not exposing the responsibility of managing your data security as a system prompt. The judgment of the LLM. You should protect your access control and data security at the respective component and the respective databases as well. Then finally, for use cases and outputs that requires human verification, that should be also designed in or factored. So with that, I'll switch to the references slide and just wanted to highlight that there are various research papers that I have come across. I don't want to make a huge list, but very crisp references to 3 documents here, especially the WASP top 10 for LLMs and agentic AI gives a lot of useful information and more detailed strategies of how practitioners go about protecting the Gen AI applications against these inherent weaknesses and challenges and vulnerabilities. I think this is a very useful. And with that, I'll end my session. Thank you. Until the next time in API Days.